Hello guys, hope you all are doing well. So in the continuation of the previous gate series, we have completed the 2011. We have left with only four questions, is which are linked question type questions. So we will see those four questions as well. Okay. So I'm sorry guys because I'm a little bit slow. I'm very slow in solving paper, but now I'm getting some time. It is my third year of the PhD, and I'm just taking out time anyhow. So uh, hopefully we'll do a little bit. We'll solve a little bit fast this year all the questions, and I have to complete. I know that I have to complete all the questions till 2026. Okay, so without wasting time, we will solve the question. So this is the linked answer type question. For a liquid flowing through a packed bed, the pressure drop per unit length of bed del P by del L is given by. So we know that this is Argan equation. Complete equation is Argan equation. This one. This is complete Argan equation. Okay. And in the 90 when like we were solving 1990s question, then I told you very specifically this is Kozeny-Kármán equation, this is Burke-Plummer equation, and bed Reynolds number. When these equations apply, when bed Reynolds number will be zero, when sorry, when Kozeny-Kármán equation will be zero, when Burke-Plummer equation will be zero. So we have solved very uh, in a very detailed way in 1990s. Okay, so where V naught is the superficial velocity, E is the bed porosity, dp is the average particle size, phi is particle sphericity, rho s is the liquid density, and mu f is the liquid viscosity. Given data, so this is the data we have given. Okay, everything is there. So when V naught is 0.005 ms, sorry, meter per second, and E 0.5, which one of the following correct value for ratio of viscous loss to kinetic energy loss? So if you know the basics, then you can easily solve this question. Okay, so we know that Argan equation is, this is complete Argan equation, as I said in the starting of the question. This is viscous loss and this is kinetic energy loss. Okay, so viscous loss is applicable when bed Reynolds number is less than 20, and kinetic loss is applicable when bed Reynolds number is greater than 2000. And you need to know what is bed Reynolds number. Okay, rho Vd upon 1 minus epsilon mu f. Okay, so that is better normal. Okay, so we have to find the ratio. So this is the ratio you can find out. Okay, just many things will cancel out here. Okay, so this is easy. On further increasing V naught, incipient fluidization achieved. Incipient means minimum fluidization. Assuming the porosity of the bed remaining unaltered, the pressure drop per unit length under incipient fluidization. Actually, incipient fluidization and minimum fluidization is two different things. Incipient fluidization is the condition when the particle is just about to move. Okay, sand particles. So this is the equation for incipient fluidization. So we have just putting all the values we have. This is the answer. Okay, so very straightforward question, nothing else. Okay, the concept is you must know about the viscous loss and kinetic law, the very detailed about these terms. Okay. Okay, second question. A binary feed mixture containing equimolar quantities of component S and T in is to be distilled in a fractionating tower, that is distillation column at atmospheric pressure. The distillate contain 96%. So XT we have, XT is equal to 0.96, and we know that where we have to locate XT here. Sorry, this is the point of XT. XT, XT. This here XT, because it is 0.96, so 0.96 will come here, right? 0.96 and 0.96. So this is XT. Okay. The Q line intersects the equilibrium line at x dash and y dash. So this is x dash, this is x dash, and this is, sorry, this is y dash because it is y axis now. This is y dash and this is x dash. Okay, and this is xf, xf. Okay, not alpha f, xf. Alpha is xf. Okay. Assume McCabe-Thiele method is applicable and relative volatility is constant. Minimum reflux ratio. So we know that straightforward there is a formula for minimum reflux ratio, xd minus y dash upon y dash minus x dash. So xd is 0.96 minus y dash is 0.66, 0.66 minus 0.46. So okay, so just calculate and that will be your answer. And uh, the feed is, so we know that there is a whole diagram about the feed. This is, so this is xf, this is xf. Okay, so saturated, sorry, superheated vapors, this is saturated vapors, uh partially vapor, that means liquid plus vapors. Then superheated vapors, saturated vapors, superheated vapors. Sorry, sorry, wait. Yeah, we can actually, there is some problem with the device, I don't know what, but the device, the pen and this is not working properly. So erase, so we have to erase this only, and I'll tell you. Okay, so now, so again pen. Okay, so we know that, so if this is the feed line xf, okay, this is subcooled liquid, saturated liquid, liquid plus vapor, saturated vapor, superheated vapor. So q is less, q is greater than 1. ऐसे याद रखना है, लिक्विड, लिक्विड में q आता है ना, तो जब q ग्रेटर देन 1 होगा तो सबकूल्ड लिक्विड, q इक्वल टू 1 होगा सैचुरेटेड लिक्विड, q 0 इन बिटवीन 1, लिक्विड प्लस वेपर, q इक्वल टू 0, नो लिक्विड ओनली वेपर्स, क्योंकि q 0 हो गया, लिक्विड में तो q आता है, q 0 तो नो लिक्विड, सैचुरेटेड वेपर, सुपर हीटेड वेपर, q लेस देन 1, लेस देन 1 हो गया यानी नेगेटिव में चला गया, सुपर हीटेड वेपर, ऐसे याद रखना है. ओके, सो दिस इज स्ट्रेट फॉरवर्ड. In an aqueous solution, reaction P, that is Q, occur under isothermal condition following first order kinetics. The feed rate is 5 centimeter per minute. Concentration of the P is 1.5 10 to the minus 4 mole per centimeter cube. The reaction is carried out in 5 liter CSTR at steady state. 60% conversion is obtained. Rate constant. Okay, so we know that the performance equation of CSTR. So this is the equation. Okay, so we know that CA equal to C naught 1 minus XA. So CA is this. So K is 0.15. Then the second question is saying the 5 liter CSTI replaced with 5 CSTI in series. Each capacity 1. Okay, so now 5 liter CSTI is replacing with the 5 1 liter CSTR in a series which has 5 CSTR of 1 liter. So we can see, so CSTR is there na. So for CSTR we know that if this is x1, x2, x3, x4, x5, so x1 will go like this, like this. Okay, okay, okay. And if I have one CSTR of X5, 5 liter, so see, so this area is not coming. So minimum the area, best reactor. Minimum area, minimum, best reactor, best reactor. Okay, so this is not good, this is good. Okay, we'll see. So tau 1 is for one reactor, tau 1 is this 2 minute. Okay, for xn that is 5, we have 5 reactors, so 0.73. See, in the first, in the 5 liter CSTR, we are getting a conversion of 60%, but when we are using CSTR 1 liter of 5 1 liter CSTR, we are getting conversion 0.73. Okay, so area minimum, best CSTR, best reactor. Okay, so straightforward question. Now, a PID controller output PT in the time domain is given by. So this is the controller output. Okay, PID controller. Okay, proportional controller is there, integral controller is there, and derivative controller is there. So it is the error. Transfer function of the process is this. Okay, so this process will come later. First, it is asking transfer function of the controller. So very first, we have to find out the transfer function of the controller. So we know that PT is this. At steady state, it become PS. Now, by subtracting 1 and 2, why? Deviation variable. Deviation variable. In terms for deviation variable, we have to subtract. So, this equation will come. Taking Laplace, this will change like this. So, PS upon ES, just take ES here and PS and this. So, this. Okay. Now solve this equation. This is little bit bigger equation. Now the characteristic equation of the loop. So we know that characteristic equation of the loop. So this is, I have solved till here for the now the characteristic equation of the loop. So we know that controller. I don't know why this is happening. Controller. This is controller. Okay, not constant controller. Process, and we have given the process transfer function load, which is 0, output y. In this case it is es. This is, sorry, in this case it is ps. This is es. Measuring, which is 0, not 0 1. We can write gm, which is 1, instant response. So now what will be the equation? So ps upon es is equal to transfer function of controller gm gc into gp, which is given 1 plus gc gp and gm. So gc is, you, it will come from here, gp given in the reaction. Okay, I think this is the answer. I think this c is the answer, so you will use, and this is the answer. I think 700. I might be wrong, but what I have remembered. Okay, so gp is there, this into this upon 1 plus this into gm is 1. Okay, so this will be your answer. You have to do rearrangement for getting answer. Okay, so we have completed all the questions of 2011. Now we will solve 2012. Sorry guys for like being so late. Okay, so